Okay, this is part 2 of section 3.4, solving radical equations. Okay, when we talk about a radical equation, we're talking about equations that involve radicals. So like something like x plus 1, square root of x plus 1 equals 3, or the fifth root of x is equal to 11. Okay, stuff like that. These are radical equations. Okay, and so when you start or introduce another principle, that's used to solve radical equations, called the principle of powers. And that one says that if you have a positive integer, so any positive or negative whole number, well, positive in this case, an integer is a positive or negative whole number. But any positive integer, or for any whole number, you call that number n. If a equals b is true, right? So two things equal each other. If this is true, then if you raise both sides to that power, that integer power, then that's also going to be true. So if a equals b, then a to the n equals b to the n. Okay, so we're going to use this, in other words, if you had something like, I don't know, 1/2 equals 2/4, and you decided you're going to square both sides. Well, 1/2 equals 2/4, right? They're the same thing. If you square both sides, you get 1/4 is equal to 4/16, which is a fourth, right? So in other words, you preserve the equality by raising both sides to a power. Okay? All right, so that is the, you know what, I'll leave that there. That is the principle that we'll use to solve these equations. So now, let's do the first example. Okay, and this is a pretty straightforward example. I want to solve square root of 4x plus 1 is equal to 3. Square root of 4x plus 1 equals 3. Okay, and so square root, if you think about square roots, that I need the opposite of a square root, which is to square something. Okay, opposite of square root is to square it. So I'm going to raise the left side and the right side to the second power. Okay, as long as I do that to both sides, I'm preserving the original equality. Okay, and so why would I do that? Because that would cancel out and leave me with 4x plus 1. And 3 squared is 9, and look how that transformed the equation, right? Transform the equation to a very simple, straightforward equation. 4x plus 1 equals 9. Okay, subtract 1 from both sides. 9 minus 1 is 8. Divide both sides by 4. I get that x is 2. Okay, and I should always go back and check them just to make sure I'm not, getting an extraneous solution. Hopefully that equals 3, right? 4 times 2 is 8. 8 plus 1 is 9. And the square root of 9 is 3. So that works. 2 works. Okay, and usually it will work unless you have a complicated equation where you're doing multiple things. Okay, when you're usually just raising something to both sides, typically you'll get a solution. Although there is a special case that I'll leave for you to discover in the homework. All right, let's do another one. Square root of 2 minus 7x equals 2. Okay, let's solve that one. All right, so same idea, right? Square root. I want to do the opposite of square root, which is to square both sides. So I will raise both sides to the second power. That's how I'm going to get rid of the square root. 2 minus 7x is equal to 2 squared is 4. Subtract 2 from both sides. Negative 7x is equal to 2. Divide both sides by negative 7, and I get negative 2/7. Okay, that's probably my solution. I'll use the calculator to help me do this quickly, but that's 2 minus 7 times negative 2/7, all into the square root. Hopefully that equals 2. I'll type in my calculator, 2 minus 7 times negative 2/7. That gives me positive 4. So that's the square root of positive 4. And we know that that equals 2. Great. So negative 2/7 is my solution. Okay, it doesn't have to be a square root though, right? We can do something else. We can do a cube root. So let's do an example of those. Okay, it looks like that. When you talk about a cube root, you're talking about a little 3 sitting there. If it's blank, right? So if this right here, this area is blank, it's understood square root. If there's a number there, then that's the root you're dealing with. So third root, fourth root, fifth root, and so on. Okay, or cube root, we'll say sometimes. Okay, anyway, the cube root of 2x plus 1 is equal to negative 5. Here's something I want to mention real quick. If you have a square root of something equals a negative, negative 5 or negative number, whatever, okay, that can't actually happen, okay? So square root of a negative, no good. But a cube root, that can happen, okay? And that's because when you deal with your sign rules. Because if you're solving this equation right here, let's change this to a negative 4. Okay, then you're asking yourself, what would I have to multiply by itself in order to get a negative 4? And you don't have any real good options there, okay? Unless you start dealing with your complex numbers, right? So let me backtrack a little bit. If we're dealing with real numbers, then you have a square root equal to a negative, it's no solution. But since we know about I now, right, those I imaginary numbers, then that could be your answers as well. Okay, so just kind of be careful with that. Anyway, that was a tangent. Let's get back to this particular problem. I want to get rid of a cube root, so I'm going to raise both sides to the third power. So raise u to the third, raise u to the third. So we're just going to say that those cancel out, leaving me with 2x plus 1 on the left. And negative 5 times itself is 25, times negative 5 again is negative 125. Okay, now we're at a simple equation. 2x plus 1 equals negative 125. We'll subtract 1 from both sides. So 2x is equal to negative 126, and then we'll divide both sides by 2 and get negative 63. Let's test it out. So 2 times negative 63 plus 1. Okay, that's the hope. So 2 times negative 63 plus 1 in my calculator is negative 125. And the cube root of negative 125 is negative 5. That's because negative 125 is negative 5 times negative 5 times negative 5. All right, so you have 3 of those dealing with a cube root. So you take that out. Negative 5 equals negative 5. Okay, that's one way to think about it. But in general, if you type this in your calculator, you get negative 5. All right, so anyway, negative 63 is the solution for this one. Okay, that example was a nice little, had a nice little tangent there. All right, we are on example 4. Just rolling right through these. Square root of 3x minus 1 plus 2 equals 7. Okay, so here's a little different one. It's different because it's not a radical equals some number, right? It's a radical, a number, and then another number. So what I need to do here is get the radical by itself. Okay, get the radical by itself. So I'm going to subtract 2 from both sides. Okay, now it's like the other problems, where I can just raise both sides to the second power. Right, second power, because I want to get rid of a square root. Square root cancels out to leave me with 3x minus 1 on the left. 5 squared is just 25 on the right. Add 1 to both sides. Divide both sides by 3. That's just going to give me 26 over 3. All right, so we'll check to make sure that that's right. 3 times 26 over 3 minus 1 plus 2 equals 7. Okay, 26 over 3 times 3 is 26, minus 1 is 25, so that's the square root of 25, plus 2 equals 7. 5 plus 2 equals 7, 7 equals 7, check. All right, good. Again, expected that one to work as well. We didn't have an ugly one yet. Okay, well, that'll change with example 12. So let's, or not 12 in this case, 12 for the full section. It's example 5 for this video. Okay, so we have the square root of 2x plus 5 equals x minus 5. All right, so this one's different. The radical is by itself, but notice where x appears, both inside and outside of the radical. So we have the potential here for extraneous solutions. Okay, I'm going to square both sides like I normally would. To get rid of the square root, which will transform the problem, although the problem is going to be a little bit more complicated than the previous ones. Square root cancels with the squared. Leaves me 2x plus 5 on the left. On the right, I have x minus 5, which, remember, is the same thing as x minus 5 times x minus 5. So I need to multiply that out. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Before I go any further, I'll combine those two. That's negative 10x. Negative 5 times negative 5 is positive 25. Okay, it's a quadratic equation, so I need to get the quadratic side equal to 0. Okay, usually I make the right side equal 0, but since I already have x squared and all the other stuff here, I'm just going to make the left side equal 0. Subtract 2x. Subtract 5. So those can cancel out and leave me with 0 on the left. X squared minus 12x plus 20 is on the right side. Now I can either use the quadratic formula or factor it, complete the square, whatever I want to do here. I'm just going to factor this one real quick. I need two numbers that multiply together that equal a positive 20, but added to be a negative 12. So they have to be multiplied to be positive, so they can both be negative. Or they can both be positive, but since they have to add up to be negative, I know they both will be negative. And what, 2 and 10, right? 2 times 10, negative 2 times negative 10 would be a positive 20. Negative 2 plus negative 10 would be the negative 12 here. All right, so use a zero product property to set them both equal to 0. X equals 2, x equals 10. All right, like I said, we have the potential for extraneous solutions, so I definitely need to go back and check both of these, 2 and 10. Okay, so our original equation, square root of 2x plus 5 equals x minus 5. I'll go plug them both in. The square root of 2 times 2 plus 5 equals 2 minus 5. It's going to be 4 plus 5 is 9. Square root of 9 equals negative 3. 3 equals negative 3. No good. Okay, so I will say that 2 is not a solution. Let's try 10. 2 times 10 plus 5 equals 10 minus 5. 2 times 10 is 20, plus 5 is 25. 10 minus 5 is 5. Square root of 5, square root of 25 is 5. 5 equals 5. So 10 is my only solution. All right, so now let's get to the really ugly ones. So example 6. Square root of 2m minus 3 equals the square root of m plus 7 minus 2. All right. So for this one, the best you can do is get one of the radicals by itself first, which is what I did already, right? I have the square root of 2m minus 3 by itself already. I'm going to go ahead and square both sides. And that's going to look weird, but it'll work. Okay, the left side, easy enough. Square root and the square will cancel out. So it eliminates one of the square roots. That's nice. The right side, though, is going to be a little challenging. Remember, square root, or when you square something that has multiple terms, right, what you're really doing, just like in the last example, this is just an uglier version of that, you're multiplying the same thing times itself twice. So I'm going to be real careful how I do this one. Okay, let me maybe color code this one a little bit. This is the first term. Square root of m plus 7 times the square root of m plus 7 is going to be the square root of m plus 7 squared. Right? Usually you square the thing. But what does that mean? Those would cancel. It's just m plus 7. Okay? So the square roots multiplied and canceled each other out. That's nice. Square root of m plus 7 times negative 2 is going to be negative 2 the square root of m plus 7. So we still have a radical there. Okay, we also have to distribute the negative 2. Negative 2 times the square root of m plus 7 is negative 2 the square root of m plus 7. And negative 2 times negative 2 is a positive 4. Okay? And so now, let's combine like terms to clean that up. And see that that actually does make the problem easier. Okay, let's see. M, there's no other m's outside, so that's going to stay there. 7 plus 4 is 11. Negative 2m, negative 2 square root of m plus 7. Negative 2 square root of m plus 7. There's two of those. You know if that were negative 2x minus 2x, that would just be a negative 4x, right? So in this case, instead of x, though, this is like the variable, the square root of m plus 7. So in other words, this is minus 4, the square root of m plus 7. Okay, we have only one radical now, right? Which is better than when we had two. So what I need to do is get that radical by itself as best I can. I don't actually want to get it all the way by itself, but you'll see what I mean. Get it by itself, and then we'll square both sides again. So let's say, okay, here's my new problem, brand new problem. We're going to start at this point. So subtract m, subtract 11. I'm going to leave the 4. Okay, I'll leave the 4. You'll see why. Usually you want to get the radical by itself like we've been doing, but if it's just something multiplied to the radical, it's actually easier just to leave it attached for now. We could take it away later. So I'm going to square both sides to get rid of the radical. Okay, and like I said, remember, if this is just multiplied together, just leave it. It's easier. Okay, so that's m minus 14 times m minus 14 equals the square. Remember, when you square something that's multiplied, you just square them individually. So that's negative 4 squared, which is 16, and the square root of m plus 7 squared, which is just m plus 7. Okay, so this is not the worst thing to deal with. Okay, let's distribute. M times m is m squared. M times negative 14 is negative 14m. Negative 14 times m is negative 14m. Negative 14 times negative 14 is a positive 196 equals distribute the 16. 16 times m is 16m. 16 times 7 is 112, I believe. Double check that. 16 times 7, 112, yeah. Okay. I'm going to go and combine these like terms right here, right? Negative 14m minus 14m is negative 28m. Okay, we have a quadratic. Let's get it equal to 0. Subtract 16m from both sides. Subtract 112. So we have m squared minus 44m plus 84 equals 0. All right, so these numbers are pretty big. So I might want to use the quadratic formula instead of trying to factor this. I mean, I could try to factor it. Actually, you know what? I'll just factor it. And the reason why I say that is because I just saw it. Also, if you want to use the quadratic formula, of course, you're free to do that as well. Okay, so I know that they both need to be negative because whatever numbers go here and here, they have to multiply to be positive. But they have to add up to be negative. Okay, so they have to be negative and negative. Okay, so what times what would give me 84? Okay, well, 2 and 42 do that. Okay, 2 and 42. And the reason why I know that's the case is because if I multiply those together, I get 84. If I add them together, I get negative 44. Okay, again, if you didn't see it factored, it's fine if you use the quadratic formula. All right, set them both individually equal to each other. No, not to each other, equal to 0. So I get 2, and I get 42. Okay, I need to check them. I need to check 2 and 42. Okay, so let's do 2 first. The square root of 2 times 2 minus 3 equals the square root of 2 plus 7 minus 2. Okay, that's 4 minus 3, that's 1. Square root of 1 equals square root of 9 minus 2. So 1 equals 3 minus 2. 1 equals 1. Check. 2 works. Let's try 42. 2 times 42 minus 3 equals the square root of 42 plus 7 minus 2. Okay, that's going to be 84 minus 3. That's 81. Square root of 81 equals 42 plus 7 is 49 minus 2. 81 is 9. Square root of 81 is 9. Square root of 49 is 7. 7 minus 2 is 5. So 9 equals 5. That's no good. Okay, so we'd say 42 is not a solution. All right, so that's actually about as ugly as they're going to get. Okay, and let's kind of retract real quick all the stuff that went through here. There were 2 radicals, so we got one of the radicals by itself. It was already by itself, but we took care of it by squaring both sides. Okay, that gave us another equation, okay, where there was only one radical. Okay, so then we squared both sides again. That led us to a quadratic equation, right, from like 3.2, section 3.2, quadratic equations. Then we solved that by factoring, one of our methods. Then we checked our solutions and found that 2 was the only solution. All right, let's do one more that looks ugly, but once you start working it out, you see it's not. So example 7, last one. Square root of y plus 7 plus the square root of y plus 16 equals 9. So it looks just as bad as the other one. Let's work this out like we did the last one. Get one of those radicals by itself. So I'm going to subtract y plus 16, or the square root of y plus 16 from both sides. So square root of y plus 7 is equal to 9 minus the square root of y plus 16. Let's go ahead then and square both sides. Square the left side, square the right side. Left side's easy. Those will cancel out, leave me with y plus 7. Nine minus square root of y plus 16 squared. Okay, remember how this works. I'm going to go ahead and rewrite this as 9 minus the square root of y plus 16 times itself. 9 times 9 is 81. 81. 9 times negative square root of y plus 16 is negative 9 square root of y plus 16. Negative square root of y plus 16 times 9 is negative 9 the square root of y plus 16. Notice this is just going to always be doubled, so you can actually skip that step and just double 9 and get 18 there. We'll do that in a second. Square root of y, or negative square root of y plus 16 times negative square root of y plus 16 is a positive y plus 16. All right, good. So now, like terms, right? Like terms. 81 plus 16 would be 97. And these two are negative 18 square root of y plus 16. Okay, let's try to get this by itself. So we're going to subtract 97 from both sides. 7 minus 97 is negative 90. Oh, well. I just realized I left something off. Hold on. I got excited. Plus y. There we go. Okay, I left that off. All right, yeah, I don't want to leave that off because then my problem is going to get more complicated. Okay, so let me go back. I want to get this by itself. So I'm going to subtract 97 from both sides. I'm also going to subtract y from both sides, right? I need to get rid of that y there on the right. Well, getting rid of that one got rid of that one, so that made my problem easier. That's why I didn't want to leave that off. Okay, and then 7 minus 97 is going to be negative 90. Okay, and then I could square both sides now, but maybe you recognize something, maybe not. 90 is divisible by 18. So if I divided both sides by 18, well, I should say negative 18. Let me go ahead and actually write it out this time. If I divided both sides by negative 18, those cancel out. I'm left with 5 equals the square root of y plus 16. That's as easy as the original problems, right? The very, very first ones that we did in this section. Because all I have to do now is get rid of that square root by squaring both sides. So 25, 5 squared, 25 is equal to, square root cancels out with the square, y plus 16. Subtract 16 from both sides and I get 9. 9 is maybe my solution. I still have to check it. So, square root of 9 plus 7 plus the square root of 9 plus 16 equals 9. 9 plus 7 is 16. 9 plus 16 is 25. Square root of 16 is 4. Square root of 25 is 5. 4 plus 5 is 9. Check. it works. So 9 is my solution. By the way, if this were to not work, right, let's say, well, why did I say 9 equals 5? What a weirdo. 9 equals 9. I don't know, whatever. Okay, so since this worked out, then it works, right? We'd say that 9 is our solution. If it did not work out, let's say we had gotten 9 equals 5. Okay, I guess I got ahead of myself earlier. If we got something like that, then you would say this one, the only possible solution that we had didn't work. So we would say this one had no solution. Okay, but of course that's not the case. 9 is the solution. All right, hopefully that last one didn't jack you up too much. That is section 3.4.